Welcome everyone to this bite-sized session looking at decimals. When we looked at the bite-sized topics, we were looking at some of the things that people tend to get right and not right in the test, the feedback we get from people of what they struggle with. And decimals is one of those things that's a relatively basic level of maths in terms of it's one of the first things you need to know, but actually it's quite easy to get wrong. So we felt that this was a good session to go through just to give everybody an underlying. So you may find a lot of this, you go, well, yeah, that's obvious and I knew that, but that's a good thing. If you are thinking that, then that's a really good thing because that's so you're aware of it and hopefully you will learn something as well. So what I'm hoping to go through in this session, I've sort of got two parts of this session. In effect, it could be two sessions, but first of all, we're going to look at what each digit number represents according to its place value and knowing how to round numbers, which is one of the key things involved in decimals. And then, as I mentioned, completing calculations without a calculator when it involves decimals is particularly a bit different to when they haven't got a decimal. So I'm sort of going to split it and go through that the digit representation and rounding first, and then look at working without calculator. There is another session that the decimal places actually were they're not invented because I suppose they were found, because I suppose they've always been there in nature, but they were found by the Chinese. I think it was the 3rd century BC. So they've been around for a long time of decimal places, and it's just part of calculations that we do. And if we're thinking about basic number systems, we count in whole numbers 1, 2, 3, 4, 5, 6, 7, so on. But what decimals tells us is there's actually numbers in between each of those, what are called integers, or in between those whole numbers. So between 3 and 4, rather than saying 3, we can actually split it down into decimal points. So we have 3.1, 3.2, 3.3, 3.4, and so on and so on. 3.9 and then 4. So we've got those decimals there. But actually, between 3.2 and 3.3, we could add another decimal point. 3.21, 3.22, 3.23, and again we can go again 3.221, 3.222, 3.223, and so on. I don't worry, I won't go on for this for an hour, don't worry. And we keep going splitting those down. So between each number is 10 points, but we can split that down into as many different decimal points as we want to. So that's why we have decimals and where we have decimals. One of the key things to look at is what we mean by place values then. So what do our numbers represent? So I've got a random number on the screen, 5783 point or dot 528. And we probably know, starting from the left, probably most common, that our 5 there is our 4th number going upwards. So that's our 1,000 number. So 5 there represents 5,000. The 7 represents 700. The 8 represents 8 tens, which we call 80. And the 3 represents ones, sometimes called units. People tend to call them ones now rather than units, and as 3 individual ones. So our number left-hand side of our decimal point is 5,783. And we've got thousands, hundreds, tens, and ones. Very similar, symmetrical pattern going the other way after our decimal point. Can anybody tell me what the place value of the 5 is? So we've got 5783 point, and then this first number 5 here. Can you tell me what that number is representing, or what place value that has in the chat? And if you're not sure what I mean, don't worry, because I will explain it. So we've got 5,000s, 700s, 8 tens, and 3 ones, and then 0.5. And what does this 5 represent? Is it equal to half a 1? Okay, I'll tell you then. So the 5 represents tenths. So there are 5 tenths, and if you think about it, there are 10 tenths, as you can probably guess in a number. So I think it was Hazel mentioned it's half a 1. And so, yeah, halfway through 10 is 5. So we've got 5 tenths. And if we go upwards, back reflecting the other side of the decimal point, we have 2 hundredths and 8 thousandths. So we've got 5783.5 tenths, 2 hundredths, and 8 thousandths. And we could go on and go on both to the left and to the right. So we have as many decimal points as we want and as many numbers to the left as we want. Not too important that you recognise those, although it's useful to know those. What is useful to know, and I think Steve has just put in the chat as well, that this 5 is also known as 1 decimal point, which I'll just put DP here. Let me just get the line on there. And then if that's 1, we go 1 more, gives us 2 decimal points, and we go 1 more and gives us 3 decimal points. So that's slightly more important to know. So I'm just beeping. All right, I don't know whether people lost me then, but I had a strange noise on my screen, and hopefully I'm all back with you now. You can still see the presentation. So what I was saying, if you missed it, is the 5 is our first decimal point, and then the next number is our second decimal point, and 8 is our third decimal point, and so on and so on. So we count from the dot onwards. First number after the dot is our first decimal point, then second decimal point, the third decimal point. That's quite important when it comes to rounding. So we'll look at that next, but to bear that in mind that it goes up from the first number after the decimal point is 1, 2, 3, and it goes up to the right. So if we're looking at rounding whole numbers, which I want to do first, one of the things that you probably know already is that you look at the next digit. And if the next digit is 5 or more, you round up, and if it's less than 5, you round down. I'll show you what we mean by that. So let's take our main number, and I've got rid of the decimal points for now. So our number was 5,783. If we want to round that to the nearest 10, well, we said this 8 figure here is our 10th figure, so there's actually 8 tens. So that's the number that we're looking at. So we want to round to that level. And what's sometimes useful is to draw a little line there and then look at the number after the dot, after the line. So in this case, it's 3. If we look at the top, it says that if we have less than 5, we round down. So our answer for this, for the nearest 10, would be 5,780. So we've taken that 3, and because it's less than 5, we round it down to 80. And if you think 5,783 is closer to 5,780 than it is to 5,790, so that makes sense why we round down. I clear my ink. Now, if we wanted to sneak the answer there away, if we want to round to the nearest 100, well, 7 is our hundreds figure. So we'll draw a line there so we know where we're looking, and we're looking at the figure next to it, which is after it, which is the 8. And if we look at our rule top right, it says if it's 5 or more, we round up. Well, it is more than 5. 8 is more than 5. So we're going to round this 7 figure up to the next 100, which would make our figure 5,800. And again, if we think about it, 5,783 is closer to 5,800 than it is to 5,700, which is why we round up. And then final example, if we want to round to the nearest 1,000, again, we're looking at our figure here. Our thousands figure is 5. Let's draw a line. The number after that line is 7, or 7 is more than 5, so we need to round up. So our nearest 1,000 figure is 6,000. And again, we're closer to 6,000 than we are to 5,000, so that makes sense. So the ruling that we're doing is that we're looking at the figure and then looking at the figure we need to think about, we're rounding to, in this case was thousands, and then we round up to the, depending on what the next figure is, whether it's 5 or not. We do exactly the same with decimal points. So we'll keep our 5,783, and we can sort of forget about that a little bit because that's going to look after itself. What I wanted first of all is think about rounding to 1 decimal place. Well, we've said that first decimal place, our 1 decimal place is the number 5 because it's the first number after the decimal point. And if we follow the same example that we did a moment ago, I'm going to draw a line after the 5 and look at the next figure. Well, the next figure is 2, which is less than 5, so we're going to round down. So therefore, rounding to 1 decimal place gives us 5,780.5. So the key here is when it's saying it's rounding to 1 decimal place, it only wants 1 figure after the decimal place, which is why it says 1 decimal place. If it was saying 10 decimal places, we have 10 points there, but we haven't. We only got 1 decimal place. So we need to go through the same process that we did before, where we look at the number that's 1 decimal place in, look at the number after it, and because that's less than 5, we round down. Next question then is to think about how we round to 2 decimal places. Following the rules that I've just done, can anybody tell me what our answer would be if we round that top number to 2 decimal places? Following the rule that we just did, what would our answer be? I'm just going to look at the chat. What it would be if we round to 2 decimal places. Some answers coming through, and correct answers coming through, which is good. Great, most people are getting the right answer there. So let's have a look at what we're talking about. We're talking about 2 decimal places. So this is the number that we want to round to. We want to round to 2 decimal places. Let's draw a line after it. The number after this is an 8, which is more than 5. So we need to round our 2 up to 3. So our answer becomes 5,783.53. Let's go through that again. We want 2 decimal places, which is our 2 figure. Draw a line after it, and we know the next number is an 8. So we need to round our 2 up to 3. And he wanted to 2 decimal places. So we've got 0.53, which shows us 2 decimal places. And following the same rules again, if we want to round to 3 decimal places, well, our decimal place where we want to round to is this number 8. We've got nothing after it, so there's nothing else we can round. We can't round up or down because there's nothing else after it. So our original figure was actually at 3 decimal places. Hopefully that's made sense. Let's give you some practice then. I'll give you a practice there, but let's give you a few more practice questions for you to try. So can you all round and put your answers in the chat if you want to? And what you think, 32.904 would be rounded to 1 decimal place. I'll give you a few seconds to do that. Remember, we only want one figure after the decimal point. That's what 1 decimal place means. It means just 1 digit afterwards. Loads of people are correctly spotting. The next number, the next number after the 9 is a 0. So therefore, we're just going to round it to 32.9. Really good. Next one, 602.115 to 2 decimal places. That's one correct. How about this one then? So we want 2 decimal places, which means we want 2 numbers after the decimal point. So we want to go to this number, but the key here then is to think about the number that's after the line. So a few people saying 0.11, but the number after our line is a 5. So what are we going to do with that figure? Great, Debbie. There we go. A few people getting the answer now. Excellent. So the answer is indeed 602.12. The key being we want 2 decimal places. So we look at this second number 1, and the number after that is a 5. And then final example, I'm going to go through is 0.8786. Now, we don't need to worry about the 0 point or 602 or 32. They're looking after themselves. We're only worried about what's after the decimal point. And here we've got 8786. Thinking we're rounding to 3 decimal places. So 3 decimal places. Yeah, loads of people getting it right. Well done. We're worried about this figure because this is our 3rd decimal place. If we draw a line, the next number is a 6. So we round it up to 0.879. Really good. Some really good answers there. Well done, everybody. A couple of things I'm going to go through just really quickly is just because I haven't mentioned this. If we wanted to round 12.6 to a whole number, basically what we're talking about is no decimal places. So what we need to look at is this number is what we're going to round to. We look after the decimal point, which is a 6. So we round it up to 13. And again, if you think 12.6 is closer to 13 than it is to 12, so that's what we round up. If that had been 12.4, we would have rounded down to 12. So if we ask for a whole number, in effect, what it's saying is 0 decimal points. And another interesting one, actually, I'm going to ask you to put your answers in the chat for this one. So 17.4, could you write that rounded to 3 decimal places? Very unlikely to be asked to do this, but I just want to check that people have understood. Brilliant, Neela. Yes, good answers coming through. And simply 17.4 means there's nothing after it. So if we did want to include 3 decimal places, we'd just have 17.400. It would be extremely rare that we do that, and it would give you a shorter number and expand on it. But basically, it means that after the 4, there isn't any. So we can actually write it in 20 decimal places, and it'd be 17.4000000 and so on. So it's unlikely you do that, but I just want you to understand that if there's nothing there, that basically means a 0. In the same way, we could, I suppose, write, if we wanted to write this in thousands, it's no thousands, no hundreds, and 17. But again, we wouldn't put those zeros in. So we don't really need those zeros after there. But if you were ever asked to do that, generally. Great, some good examples and some really good answers there. Well done, everybody. I think you've understood that. The key being, I suppose the 2 key tips is, if it asks you round to so many decimal places, that means it wants you to write that many decimal places after the point. So if we take our one with 3 decimal places, it means there are 3 numbers written after the dot. So that's what we mean by rounding. And when we are rounding, we always look at the next number. If it's 5 or above, we round up. If it's below 5, we round down.